In this video, I will show you how to build reactive microservices using Spring WebFlux and MongoDB. By the end, you will have a working microservice that handles real-time data like a pro. It's easier than you think. And trust me, it's pretty fun when you see it all come together. Ready? Let's dive in. The application handles order processing with real-time updates and data streaming. I'll use the latest stable Spring Boot version 3.04.02. It plays super nicely with Java 17 and even up to Java 23 if you are feeling cutting edge. But let's stick with 17 for stability. Alright, let's dive into building our reactive microservice. Before we get started, make sure to subscribe to this channel and click the alert button. That way, when I release more videos and more tips like this, you will get notified. If you are excited to diving deeper into the world of modern software engineering from architecture to cloud and security, check out my video courses where I explore these concepts further and tackle real-world challenges. The link to the courses is in the video description below. And here is a bonus. Subscribe to my newsletter and you will get free and discount access to my video courses. First things first. What is Spring WebFlux? Simply put, is Spring's reactive programming module. Unlike traditional MVC, it doesn't block threads. Everything works in a non-blocking, asynchronous way. That means your app can handle more traffic without breaking a sweat. It's a game changer if you care about performance. The tools you need. Here is what you will need to follow along. Spring Boot for building the app, MongoDB, a non-SQL database for our data, Postman for testing APIs, and your favorite IDE. I'm using IntelliJ, but pick what you like. You can grab all the links in the description below. Alright, let's set up our project. Project setup time. You've got your IDE ready, right? Fire it up. We are going to use Spring Initializer to get our project off the ground. Just head over to start.spring.io. Under Project, I choose Gradle, but you can select Maven if you prefer it. As language, I choose Java, Spring Boot version 3.04.02, packaging jar, and Java 17 or 21 or 23 if you are feeling adventurous. Now for the dependencies. In the dependencies search box, type in and add these. Spring Reactive Web for the WebFlux magic. Spring Data MongoDB Reactive for the reactive MongoDB database. Lombok to get rid of boilerplate. And Spring Boot DevTools. Once you've got all that, hit Generate, then download the project zip file from Spring Initializer. Unzip it to your favorite project folder. Then import this project into your IDE as an existing Gradle project if you already selected Gradle as a build tool. Let your IDE do its Gradle synchronization and dependency download thing. Once it's done, you should have a basic Spring Boot project structure, Gradle powered, and ready to roll. Gradle dependencies. Build Gradle. Here is the Gradle build file that Spring Initializer generated. This is the Gradle equivalent for POM.xml if you are working with Maven, and it tells Gradle what libraries to pull in. You can see here all the dependencies that we have selected in Spring Initializer. Step 3. Implement the models and repository. Alright, let's get our hands dirty with some code. I'm going to start by defining the data model and setting up the database interaction. First, let's create a package called model. Inside this package, I'll create an order class. This is going to represent an order in the system. Here is the source code. It's simple for now. The @document collection equal orders annotation is from Spring Data MongoDB. It tells Spring this order class represents a document in our MongoDB collection called orders. A collection is like a table in a traditional database, but way more flexible. The @data annotation is from Lombok. Remember I added the dependency? @data is a super time saver. It automatically generates all the boring boilerplate code for us, like getters, setters, toString, equals, and hash code methods. It's less code for you to write. The @AllArgs constructor and @NoArgs constructor annotations are also from Lombok. @allArgs constructor creates a constructor that takes all fields as arguments, and @noArgs constructor creates a constructor with no arguments, handy for creating order objects easily. The @id annotation is from Spring Data. It marks the ID field as the primary key for our order document in MongoDB. MongoDB uses ID as the default key, and Spring Data knows how to work with that. Next up, I need to talk to the MongoDB database. Let's create another package called repository. Inside, I'll create an interface called order repository. This is where Spring Data Reactive MongoDB shines. Here is the source code. This order repository interface is where the reactive magic really kicks in. It extends Reactive Mongo repository, which is an interface provided by Spring Data Reactive MongoDB. And it gives us a whole bunch of reactive database operations out of the box. We get methods for saving, deleting, and finding orders, all done in non-blocking reactive way. You just need to tell it what entity you are working with, its order in this case, and what the type of its ID is, its string in this case. The find by order ID method returns the Flux order type, which represents reactive streams in action. Flux is like a stream of data, in this case, a stream of order objects. When I call find by product ID, it's going to reactively fetch all orders with that product ID from MongoDB and give them to me as a stream, asynchronously and non-blocking, of course. The @repository annotation is just a standard Spring annotation to mark this interface as a repository component. This makes it eligible for Spring's component scanning and dependency injection. Okay, that's it for the data layer for now. The model and repository are done and dusted. Let's move to the service layer. Step 4. Service layer. Order processing logic. Alright, the service layer is the heart of our microservice. This is where we put the logic for handling orders. First, I need to create a new package called service. Inside this package, I'm going to create two things: an interface called order service and a class called order service impl that implements this interface. Let's start with the order service interface. This will define what our service can do. Here is the code. The order service interface is all about defining the operations you can perform on orders. Notice the return types of these methods, mono and flux. These are key to reactive programming. Mono represents a single asynchronous result. Methods like placeOrder and getOrder by ID return a mono order because they are expected to return one order object or nothing if an order isn't found. The operation happens asynchronously, and the mono acts as a promise that will eventually deliver the result. Flux order. I already talked about Flux in the repository. It's a stream of 0 to more items delivered asynchronously. Get all orders and get orders by product ID return Flux order because they can return multiple orders and they will deliver them as a stream. And here is the star of the show for real-time streaming. The method streamOrderUpdates also returns a Flux order. This method will provide a continuous stream of order updates, perfect for showing real-time data flow in our application. Now let's implement this interface in the order service impl class. This is where the actual logic goes. @service is a standard Spring annotation. It marks this class as a service component. Spring will manage this class as a bean and make it available for dependency injection. It tells Spring that this class contains my business logic. @requiredArgs constructor comes from Lombok. It automatically generates a constructor that injects all final fields in the class. In this case, it's injecting the order repository. This is how you get access to the database repository in the service. Constructor injection is a clean and recommended way to handle dependencies in Spring. In the placeOrder method, I'm generating a UUID for the order ID and setting a default pending status before saving it to the database using order repository.save method. The method getOrder by ID, getAllOrders, and getOrder by product ID directly use the reactive repository methods find by ID, findAll, find by product ID to retrieve data reactively. The method streamOrderUpdates is the cool real-time demonstration part. I'm using Flux interval to simulate order updates every 2 seconds. I'm creating dummy order objects with random product IDs, quantities, and status within the flat map. The log operator is used for debugging and demonstration purposes. The getRandomStatus helper method is just for demonstration in this example. However, in real application, all the updates would come from actual events like database changes or external systems. Step 5. Controller. Exposing APIs. Alright, let's wire up our service layer to the outside world with a controller. This is how end users or postmen for testing will interact with the microservice. The controller layer is the front door of our application. It handles incoming requests and sends back responses. I'm going to expose the order service methods as REST APIs. Let's create a new package called controller. Inside, I need to create a class named order controller. Here is the source code. At REST controller marks this class as a REST controller. At request mapping, /API/orders sets the base path for all endpoints in this controller to /API/order. At required args constructor, again, Lombok magic for constructor injection of order service. At post mapping, maps the place order method to handle post requests to /API/orders. At request body order indicates that the request body should be bound to an order object. At response status, HTTP status created sets the HTTP response status to 201 created when an order is successfully placed. The place order method calls place order from order service to process the order. With the get order by ID, I'm using @getMapping, which maps get requests to /API/orders/order ID. And @path variable string ID extracts the order ID from the URL path. The getOrderById method calls getOrderById method from order service and uses map response entity OK to wrap the order in a 200 OK response. Or default if empty response entity not found to return 404 not found if the order doesn't exist. With the getAllOrders method, I'm using getMapping to map get requests to /API/orders. Inside it, I'm calling getAllOrders from order service to getAllOrders. With the getOrdersByProductId method, I'm using getMapping to map get requests to /API/orders/product/product ID and add path variable string product ID to extract the product ID from the URL path. This method calls getOrderByProductId from order service. With the stream order updates, I'm using @getMapping value stream produces media type text event stream value. This is the real-time streaming endpoint. Value equals /stream maps get requests to /API/orders/stream. Produces equal media type text event stream value, crucially the state spring to use server sent events, or SSE, for streaming data. SSE is a simple way to push real-time updates from the server to the client over HTTP. This method calls stream order updates from order service to get the flux of order updates. Alright, controller done. We are almost there. Next up, I will configure MongoDB and then test out this API using Postman. Step 6. MongoDB configuration and API testing. So, first things first, you need to have MongoDB running. You can download and install MongoDB Community Edition if you don't have it already. Or if you are comfortable with Docker, you can use a Docker image of MongoDB just like me. It's super handy because you don't need to install MongoDB directly on your machine. Docker keeps everything contained and clean. First, you need to make sure you have Docker Desktop installed and running on your system. If you don't, head over to Docker Desktop website and download and install it. Once Docker Desktop is running, open up your terminal or command prompt to run the official MongoDB Docker image. Just write this command and hit enter. Docker run --name reactive mongo -p 27017 27017 -d mongo latest. Docker run is the command to run a Docker container. With minus name Reactive Mongo, I'm giving my container a friendly, memorable name, Reactive Mongo, to make it easier to manage. Because otherwise, Docker will just assign some automatically generated name to my container. With -p, I'm doing the port mapping. I'm mapping port 27017 on my local machine to port 27017 inside the Docker container. MongoDB uses port 27017 by default, so this makes it accessible from my host machine. The -d flag runs the container in detached mode in the background. And Mongo latest is the Docker image I'm using. Mongo is the official MongoDB image from Docker Hub, and latest means I'm using the latest stable version. Docker will download the MongoDB image now if you don't have it already, and start a MongoDB container in the background. You can check if it's running on Docker desktop or by using the command docker ps on your terminal. You should see a container named Reactive Mongo in the list. Now that MongoDB is running in Docker, I need to tell my Spring Boot app how to connect to it. Go to Application Properties in SIC Main Resources folder and add these lines. Spring.data.mongodb.ure is the connection string for the MongoDB database. MongoDB://localhost 27017 points to the exposed port of your MongoDB Docker container on your local MongoDB instance. You can use host.docker.internal as an alternative if localhost doesn't work for you. Host.docker.internal is a special host name that Docker Desktop provides to access the host machine from within a container. Reactive-order-db is the name of the database I will be using. Spring Boot will create this database for me if it doesn't exist already. For spring.application.name, just sets the name of the application. It's nice to have for logging and management. Okay, that's it for MongoDB configuration. Super simple, right? Now let's fire up our Spring Boot application and test the API using Postman. Open up Postman or your API testing tool of choice. You can create a new collection and call it Reactive Order Service. Let's test our endpoints one by one. Place an order. Create a new post request in Postman. Enter the URL localhost:8080/API/orders. In the body tab, select row and JSON. Enter a simple order in JSON format like this, with a product ID and quantity. Hit send. You should get a 201 created response back, with the details of the order you just placed, including a generated ID and the pending status. Get order by ID. Create a new GET request. Enter the URL localhost:8080/API/orders/order ID. Replace order ID with the actual ID from the order you just created in the previous step. Hit send. You should get a 200 OK response with the details of that special order. Get all orders. Create a new GET request. Enter the URL localhost:8080/API/orders. Hit send. You should get a 200 OK response with a JSON array containing all the orders in your database, which might just be the one you created so far. Get orders by product ID. Create a new GET request. Enter the URL localhost:8080/API/orders/product/product ID, or use a product ID from your orders. Hit send. You should get a 200 OK response with a JSON array of orders for that specific product ID. Real-time order stream. Create a new GET request. Enter the URL localhost:8080/API/orders/stream. Go to the Headers tab in Postman and make sure Accept Header is set to Text Event Stream. Postman might set this automatically, but it's good to double check. Hit send. Now this is where the magic happens. Instead of a single response, you should see a stream of data coming in continuously. Postman will keep receiving server-sent events, SSE, every 2 seconds, each containing a new simulated order update. As you can see, Postman is continuously receiving updates in real time. This is the reactive nature of WebFlux and real-time data streaming. So how did the API testing go for you? Did you see those real-time updates streaming in Postman? If you want me to explain or implement any more features, or you just have a question, drop a comment below. I'm all ears. That's it for today, and see you next time.